You guys can hear me?
Yeah.
Oh, okay. Just now I didn't plug my headphone. Okay. So now let's start our first class today with mm, okay. First, before we start our lecture, because last week on our first class I did skip a few patch because I said I'll get back to you later. So the first part is here. I didn't explain to you guys last week what actually hierarchy is because I didn't know last week how to implement in OOAD. Well, basically, hierarchy is a classification of an object. Uh, yeah, it's a classification or a group of object under one group. For example, there are three class here, which is object account, security, and properties. These three class is group under this one general group, which is asset. So that means asset can contain bank account, security, and properties. For bank account, you can see there's more specific class here, which is saving and fixed deposit. Same goes to security. They have more specific class here, which is stock and bond. So this one is the first one for the first lecture last week. And then the second one is the class attribute. So, okay, I go back to this first. So the class attribute is this part where class attribute can contain anything that they want to display. For this example, a professor, they can display the name, employee ID, hire date, status, discipline, and this attribute. So attribute should show something like this. For this example, there are three attributes, which is ID, the course ID, the credit, and the semester. So this is the attribute. The attribute is the course ID, credit is 3 hours, semester into. So this is another example too. And then another part last week is generalization. This one is on page. Okay, this one is on page 33. This one still on your first chapter. So generalization is how we classify a group within a larger group. That means how we group another class within a larger group. So that's generalization. This one is related to inheritance. Okay, I think that's all for last week that I missed with you guys. This is the generalization. This is the example of generalization. So this is group under this one. The class here, employee, customer, and supplier is group under the person. And then there are three more group under this employee. So that's example of generalization. So last week we stopped inheritance. Right, this one. We stopped at interface, if I'm not mistaken. Yeah, we stopped here. Last week we stopped here on polymorphism. So, okay, we start our second lecture here with interface. Interface is so what is interface in OOAD? So interface formalize the polymorphism. That's mean we need to understand what's the definition of polymorphism before we can understand what's the interface, or how it is relevant to our courses. Okay, the last week I explained to you guys what is polymorphism, but let me recap. Polymorphism actually is how the message or different message that send to different classes of an object. That means one object can send message to different classes of object. For example, I think here, yeah, allows one message to be sent to be different classes of object. That means the same message will be sent to different object. No, to different class of object. So the interface here means that how how the object can be sent to the different, I mean how the message here sent to different class of object, or how does it work, how the message, how that one message can be sent differently to different class of an object. So interface is basically how the message can be sent. So interface support plug and play architecture. Okay, plug and play, that's mean that mm, the message or how the message sent to different class should have the flexibility. Yeah, plug and play means that it should have flexibility where it shouldn't contain like any specific requirement for that class to receive that to receive the message. So that's what it means by plug and play architecture. Okay, you can see the diagram here. You can see the diagram here. Here is an example of interface. You can see here there's a mark here, mm, realization relationship. This one is how the object, realization is uh, how the object is connected. Realization relationship means that how the object can be related. It's mean for interface, right? It should contain a method. Method is, yeah, it shows, I mean like interface should contain the method of how you want to send your message to a class. So basically, the meaning of interface in polymorphism actually is how you want to send the message to different class of object. And then interface also allow we can define how uh, we can send the message. Yeah, interface allow the user to define how we can send the message. And then what is important? Plug and play. Plug and play, like I said just now, plug and play, that means it should have the flexible characteristic. That means it shouldn't use any specific method for different class. And then that's interface. This is the interface representation. So as you can see here, this is a lollipop representation. That means this shows mm, this is the this is the diagram that shows how the message sent to the class of object. That's mean for one class, the shape. This is an example of a class shape here that contain the example here is shape. No, this is the class. The class here can contain different object, which is tube, you know, this is, oh, I'm sorry. This is the object. So the object can contain different classes, which is tube, pyramid, and cube. So the message is sent within this one object. The message is sent to these different classes. But you guys understand or not? So far, you guys understand or not the meaning of interface? Any question? thing now. So this is the example. The object is contain cube and pyramid and cube. So the message is sent to these different classes. And then the canonical representation. Basically, canonical is actually a mathematical representation, or for this diagram here, it doesn't have any mathematical example, but it's actually shows how the message or how the object of the class is related. That's another example of interface. And then we move to package. So guys, do you have any question for interface just now? Basically for interface, you guys just need to know the, I think the concept of interface, how does it is relevant to the concept of polymorphism. So interface actually how the message sent to different classes of object. That's all for interface. So we move to package. I think if you guys have another course, networking, I'm not sure if you take the course or you enroll the course, you will be familiarized, you will be familiar with this term package. Package in network, that's mean it's like in networking, package is a data that you send. Yeah, data that you send. So for OOAD package, basically the definition or the concept of package is still the same. So a general purpose mechanism for organizing elements into group. So that's mean here from the first point here, package is actually like we group an element together. So that's the meaning of package. We group an element into a group. They will belong to the same group. So model element can contain other model elements. That's mean a model element that can contain another model element. That's mean in a package you can have different type or different element of different model. Then a package can be used to organize the model under development as a unit configuration management. This one I think this is the function of the package actually here. They're trying to say that to organize the model under development. For example, if you want to develop a system, a package will be used to show or to show to show the organization of a model under the development. That's mean if they want to show what's the element that contain under certain package or any particular package as a unit of configuration management. This one I'm not understand to what's the meaning as a unit of configuration management. I'm not sure about this one, but here basically they're trying to explain to you what package is. So you need to know that package is a group of elements that group together, and then the element can be different element from different model. So that's the explanation for package. And then this is example of package. So as you can see here, the one package, this is the university artifacts. This is the package that contain student artifacts. So the student artifacts can contain different element, which is course, student, course offering, schedule, professor. So they can contain different model from different element from different model. So this different element from different model will group together under one package. So this is one package. So this package contain the different element from different object. You guys understand the meaning of package? So I assume okay. So this is the example. I think it's quite easy actually. So this is one package and then the element of the model, and this one you guys can try later. This one is the example of interface just now. What does the following represent? This is the one I said just now. This is a package. This is a package. This one, test yourself. What does the following represent? This one I think should be best from our last week class. As you can see here, there's a class, the sender and the receiver, and then message, content, sender, return value X, message. This one represent the polymorphism, because why I say it is a polymorphism, because you can see the message content sent to different type or different class of object. So this is a this diagram represent a polymorphism. This diagram actually you can go back to the previous note. Yeah, you can check the previous note. So benefit of object-oriented approach. So this is, I think, more to explanation why you learn this object-oriented. Mhm. So the first benefit is the concept of class. So the first benefit is the class, object, method, message. This one is what now? So yeah, why we use this class, object, and method, message, or why do we need the diagram like the UML diagram when you present your system or you analyze your system? Present your system. Why does this is bring benefit, or why it is bring benefit to your system? So the first one, more realistic way for people to think about their business. So actually, when you are working, instead of explaining, can content package or content. Wait, I already record. Yes, I wait. Okay, same concept in our PC. PC is, what do you mean PC? PC?
Computer.
And what do you mean by computer? Oh, PC, same concept folder. Yeah, you mean the folder in our computer. Yes. Wait, someone accept me. Oh, okay. Yeah, same concept as folder. Yeah, your folder can contain file. Yeah, that's correct. Can package content package. You mean sub package? Usually, if they have a more specific element that they want to group together, and then they want to put that package under package, that one can, and yeah, that one can package content package can. But that one, I think for your level, you just need to know. I don't think you will be. Usually, if you present your like any diagram, right? Usually, that's more than one level. That's mean this one. If you have like let's say if you have another class here that have sub package that is another level. This one is consider is first level. If you have another package here, it's considered as second level. But yes, can. And then what else? Okay, so guys, I think if you type something there, you need to raise your hand because I didn't get any notification. So, more realistic way people to think about their business. This one just now I said in working, usually instead of documentation, like because when you develop a system, actually there are many documentation. So instead of we explain to the user um, in word or in text method, we usually represent the system. For example, I think you will learn this later, the DFD, data flow diagram, or ERD, entity relationship diagram. So the diagram shows how the system or how us human interact with the system. What is the interaction between human and the system. So that's why we use class, object, or the benefit. That's why we use object oriented. For example, last week on your class, we have a UML diagram. So we can, or user can easily see what's the class or what the attribute or what the message in the for your diagram. So that's easier for them. They contain both data and process. Yeah, in your diagram can contain any data. In UML diagram can show the message and the data. So this is the benefit, better communication between the BA or user and the analyst developer. So this is the communication between the BA, business analyst, or mm, the client. It's easier to communicate between the client and BA. Reusable object benefit from having a cohesive system. Reusable object benefit from having a highly cohesive system. Cohesive, cohesive system. What is it now? I forgot already. Cohesive system, if I'm not mistaken, cohesive system is yeah, I forgot already. Cohesive something like if you have or if you develop a different or no, if you develop a complex system, cohesive system, that's mean you when you receive a threat or a bug or any issue, you can see it from the diagram. That's mean after you already yeah, after you already draw or illustrate your diagram, you can see if your system will have any threat or not. Yeah, that's a cohesive system. So that's how it is bring benefit to OOAD. And this one, encapsulation and information hiding. Encapsulation, like explained, encapsulation last week is a binding, binding process, which mean you it's not like a package, but that's mean you binding your data into a you binding your data into a method. You binding your data into a method and information hiding. Information hiding that's mean you doesn't the information hiding that's mean you doesn't need to show any of your data or any of your because when you because there will be many data or your data will be for complex system there will be many data, so encapsulation and information hiding that's mean from the diagram you can show only what's like the attribute. You don't have to be specific. And then loosely couple units, visual object view. I think this one you can just read this, but the concept you need to understand why you use the OO approach. And then inheritance also last week, inheritance is mm, where we allow discuss. That's mean inheritance. I think from the terms here you can understand what is inheritance. That's mean you can use the template, or you can use if you're doing programming or you're doing coding inheritance. That means you can call back the function or you can reuse. Yeah, that means you can reuse back the function. That one is the inheritance. And then polymorphism and dynamic binding. I already explained polymorphism, but for dynamic binding is the combination of polymorphism and the interface, this inheritance. The concept of polymorphism and inheritance. You combine these two together, become the dynamic binding. Minimal messaging that is interpreted by object themselves. Yeah, this one you need to know the definition of polymorphism and the inheritance, because dynamic binding combine two concepts, which is polymorphism and inheritance. So uh, it will support the minimal messaging that is interpreted by objects themselves. So the object that receive the message or the receiver will interpret their own. message. This one also the you can read this one because this is only the example. It's not example like mm, what is the outcome or yeah, what is the outcome from this benefit? So that one use case driven and use case. Oh, okay. Use case driven. There's another example here which is use case. Yeah, use case you will learn in chapter 3. By the way, use case is a diagram that shows what the relationship of your system and the human. It's like it's diagram that shows step of process that shows the interaction between human and the system, and then allow user and analyze to focus interact with the system. Yeah, this is the keyword here, the interact to interact. Basically, we learn that you will learn about the use case diagram in chapter 3. So use case diagram shows how the human or how the user interact with the system to perform a single activity. The the what's the term? The relationship will be shot as a step-by-step process. This mean by step-by-step process here. And then better understanding and gathering of user needs and better communication and between and user analyst. Yeah, actually for use case diagram, it is very useful because sometimes when the client or the user explain to business analyst the requirement or what they expect from their system, sometimes the BA, the business analyst will misinterpret misinterpret the system or the requirement. So the use case diagram can show better understanding. That means the use case diagram will show exactly how the user can perform a single process. For example, even for small module, for example, I take any system for login. Yeah, login is easy for you guys to understand for any module lah. For example, login. Even for login, they need to draw a diagram to show the programmer or to show the back to the client what it is expected. So that's mean it's easy for them to understand. And this one also is very useful when you design a test script. The script is a script or a step that a user will use to test the system. That's mean from this you use case diagram, they can come out with test script which will be used later after the system has been developed or finished. Architecture centric. Another benefit here is architecture centric, functional, static, and views. This one architecture. Um, I think you will learn this in chapter. No, it's not. I think you will learn this in chapter 9. But if I'm not mistaken, architecture means what the elements that you should have in your system. That's mean when you draw a diagram, you will show everything or every element that you need to use or will be used in your system. For example, here viewing the evolving system from multiple point of view, and then better is modeling of user more complete description of informatic. I think this one we will cover later in chapter 9, but basically architecture is useful. I mean, or object oriented is useful to, I mean, no. I mean, one of the benefit is the architecture where it will show the element or when you when you want to draw a diagram, right? It will show all the elements. So it will bring benefit by showing what is needed in your system. That's that's the main by this concept. And then iterative and incremental development. This one is more to the life development, system development of your system development life cycle, the process how to develop the system. So iterative and incremental development. This one we will cover later in a moment. Support continuous testing and refinement of the development system. Continuous testing, or known as regression testing, that's mean let's say after you develop one module, because a system can contain many module. So after the developer already done, or programmer finish the one module, they will do a tester usually do a regression testing. That means after programmer done, they give to the tester, and then if tester found a bug or any issue with the system, they will give back the system to the developer. And then the developer will fix back and then do the pass to the tester. So the tester will do the same testing again. So continuous testing or regression testing means that they will mm, do the testing again and again until the bug is not longer observed in the system. Real needs, yeah. Meeting the real needs, that mean this is what the user expected. So no more bug, that's what is continuous testing. Higher quality system. Yeah, this is no more bug, so it can consider as higher quality system. And then the disadvantages. Just now is the advantages. So this is the advantages of object oriented. You guys have any questions so far? No?
No.
So we go to disadvantages. So basically, the only one disadvantage, which is time consuming. Large scale change to new technology and method. Yeah, because if how should I say that? Large scale change to new technology and method. That means if you want to adapt, or if there are any new technology or any method that you want to adapt, the adapt is, I mean that you want to change to new technology or method, they will need a large scale changement, because once you already start your project and you use the your current or existing method, then suddenly you want to change, or suddenly there are new technology, then you want to adapt the new change. You need to do again from the scratch your um, like for example, you already start and then there's no technology, so you want to change back everything, you need to start back from sketch. So it will more, you will take more time, because yeah, you will take more time because you need to start back. And then productivity and quality staff learning new methods. Yeah, so because I think this is common when you want to learn something new, or you want to adapt, or you want to implement new method, it will take time for the user to adapt or to learn, because usually the company will send for training. They will send the staff for training if they want to adapt any technology or method to apply. So it will more time consuming, and the what period of the project development of project will take longer. And then the third one, if oh yeah, the third point, if management looks for quick fixes and short-term investment, it will fail, because you need to, usually before we develop a system or anything, we will fix with one method. That one method you will use starting from the early phase until your last phases of your development. Last phases should be implementation. That means you already implement your system, and then it's not it's not good, or it's not suggested, or your development will not be failed. But for your documentation, there will be a lot of changes, so it can be considered. So it is not suitable. And then summary, this one you already learned. This one is last week. Fundamental principle of concept of object oriented. There are four concept principle in the earlier of this lecture note. And then some of the advantages. This one is just now. Keyword, yeah. This one, like I said just now, there are four principle. You need to know abstraction, encapsulation, modularity, hierarchy. So this is the concept that you know, object, class, attribute, operation. This one, I think, if you did your tutorial last week, when you draw a diagram, you should know what is object, class, attribute, operation. Interface, just now the concept, interface is how the message sent to different class of object. Polymorphism is the message that's sent to different class of object. Package just now is like a grouping of an element into the same group, and package can have sub package, but that one is quite complicated if you have sub package. And then yeah, that's, I think, this is the exercise. So yeah, this is the UML class diagram. You need to draw a UML class diagram that implement the generalization and specialization of hierarchy. This one you can go back to the previous lecture note. I'm quite sure there's an example for this diagram. So for construct an object diagram for employee object. Okay, this one also you can try. But if you have any question, you can ask me during the tutorial regarding the exercise or how to write a diagram. So you guys have any question? What is not really? Rachel, what do you mean by not really? No question. Okay, I want to tell you guys, since you guys have no exam, right? I think I already informed you guys your full assessment will be on assignment. So I think it's not, I think. Uh, this is very important. The diagram. Sometimes you think that you just need to learn this course because you need to finish your assignment. But actually, I want to share with you guys something. Mm, Last time, during my job hunting, I went to an interview with a quite big company in Selangor, in KL. Yeah, in Selangor, in KL. Usually, when we want to go to the industry, right? Because I apply for a position as a programmer, yeah, as a programmer. So usually they will give us a test. That means it's up to the company. They want to test us in programming skill, or they want to us to write a code. So it's up to them. Usually for programmer, they will ask us to write a code, simple program. They will give us like 1 hour. Yeah, usually 1 hour for us to write a simple programming code. So my point here for these courses, object oriented, you need to understand the diagram, because I still remember I got an offer from a company, because last time when I went to an interview with a big company, so there are many people back then apply for that position. And then last time I still I just have my internship program experience for 6 months. That's not enough for me to compete with the those who already years with strong background. So during the interview, I still remember they asked me after, oh, of course, we need to introduce ourselves. So after I introduced myself, the people there straight give me a piece of paper, a piece of paper. So on that paper, there are diagram. Then he asked me, what is that diagram? He didn't ask me for any specific attribute or any specific class. He just asked me, do you know what is this diagram? Then I still remember, because yeah, I learned from this course too. So I said that's DFD, data flow diagram. So even just with that one simple diagram, I beat the other competitor with a strong background. That means they're already working in the industry for so many years. Then the people there told me, they said, I'm the first one that answer his question, because they already, the people, the other, my competitor, they claim they have experience, but they did not know that basic thing for us to know for this industry. So I think it's quite important for you guys to know what is UML diagram. At least you doesn't need to know what is the specific attribute or any specific attribute. At least you need to know. If people ask you, you need to know. Or if they show you like the UML diagram, you can tell them this is UML diagram. Usually they won't go for deeper question like what's the class? Okay, what's the class? So That's my point. You at least need to know if they show you like any diagram, you need to know. Usually they won't ask you what is the relationship between this entity and this entity. They won't ask you. They just want to test your concept or your understanding on your knowledge. So that's my point. I think you guys can understand, right? Even though you don't have exam, you need to have know exactly, or at least know what is the diagram that you're going to draw. So yeah, that's my experience. So I think we move to chapter 2. Okay, we move to chapter 2.
Miss, sorry, the exercise, do we need to do it for tomorrow?
Tomorrow,
Yeah, the chapter
tomorrow
one.
tutorial. I,
Yeah.
for your better understanding, I think it's better for you to draw, the diagram.
Oh, so do the question one and question two, right?
Yeah, should be okay. You should do.
Oh, okay.
Okay, any more question? So this is chapter 2. I think I already upload the whole syllabus to the this one. Yeah, I already upload. Eh? Oh, syllabus. Yeah, I already upload. You can find this. So we move to chapter 2. We move to chapter 2. So in this chapter 2, we will learn about unified software development, or known as USD. I will explain later what is unified software development. So the objective or the outcome of this chapter is we will learn about this traditional waterfall, or for system development life cycle. Actually, for SDLC, there are many model of the cycle. One of the model is traditional waterfall. This is the most common model for SDLC. SDLC actually is very important. You need to know what's the term SDLC. You will hear it a lot if you go work. You will hear the people will say SDLC. So SDLC is system development life cycle. Actually, there are few model in SDLC. For example, the traditional one is waterfall, and then there are what is iterative model, and then there are few more model, but the the one that we will learn here is traditional waterfall. So USDP stands for Unified Software Development Process. We'll explain later. And how PES relate to workflow in an iterative life cycle and activity diagram. Okay, you will learn this in this chapter. So, okay, waterfall model development. Okay, first we will start with waterfall model. Waterfall model is one of the model under SDLC. SDLC, like I said just now, software development or system development life cycle. So waterfall model is a framework for software development in which development proceeds sequentially through a series of phases, starting with system requirement, analysis, and leading up to product release maintenance. Okay, so for waterfall model actually, um, what is it mean by sequentially method? So when you develop a system, you will have like a phase or process or flow that you need to follow. That's mean after you already done this one phase, what's your next step, or what's your next phase you need to do in order to complete your system development or software development. So what does it mean by sequentially through a series of phases? That means you have few phases for this software development. Software development. For this waterfall model. For yeah, for this waterfall model. So actually for the first point, it's not really explaining about the waterfall model, but it's actually tell you what software development is. So basically software development is a process to tell the, not to tell. Software development is a process that show the phase for a system to complete. So the keyword here is phases. So in, yeah, framework, you need few phases. It's actually the phases is not fixed. For different model, you have different phases, but basically they're only the same. It's just the flow of the of your model. And then this one is feedback loops exist between each phase. Okay, feedback loops exist between each phase. I think this one I can explain later, but that means feedback loops exist between each phase. So I think there are room, or they, after you already finish one step, for example, there are 5 steps: step 1, step 2, step 3, or phase 1, phase 2 until phase 3. For example, you're already in phase 3, you can go back to phase 2, but that one follow your model. Not all model allow you to go back to your previous phase. That one. Okay, we will start the waterfall model software development. Okay, basically, yeah. So this is the example of, it's not, no, this is the module, or this is the flow of the waterfall model. So as you can see here, 3, 4, 5, 6, 7. You can see here, there are 7 phases or 7 steps for waterfall model. The first one is system engineering. System engineering is actually something like, wait, let me type something. Right. This one should be something like planning. Planning. Yes. Is it correct? Planning. So the first phase, usually the planning. The planning is the how you're going to go through of this phase, or like the planning of your overall system. Basically, this is the earlier step, the first phase of your development. So planning usually will involve the client and the business analyst. Business analyst, yeah. So then requirement analysis. This is the process after you already, this is usually the, no, this is the second process or the second phase. This is the phase where the business analyst, I think I already explained to you guys last week, right? Business analyst is a person or a team that involved to communicate between the client and our company. So they will send this BA to the client to discuss or talk about the requirement of the system, or what do the user expect. Yeah, what do the user expect? So the BA will do the requirement analysis. After they get all the requirement, either it is functional or non-functional requirement from the client. So they will analyze all the requirement, and then they will go for design. Design this actually, for this process, actually for the typical or the, yeah, typical model, there are only 5, which is planning. Here is analysis, ALYSIS, and then that one is design. S, S2 implementation, or installation, ADIM, M. So basically, actually, can I move it? This, wait, I want to make it easy for you guys to understand. Should move here. Maintenance, this one, implementation should go here. Yeah, 16. Okay. 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 So basically, there are only five. Basically, there are only five of these phase for waterfall, which is planning, analysis, design, implementation, and maintenance. But here in your lecture note, they split this design. It's not split. What's the term? They they divide to another three or more step, which is design, construction, and testing. Actually, for typical or normal development, they will conclude this together, these three phases under the design. Design here, that means after the requirement, after the done the analysis, design the BA will work together with programmer to design how the system should, uh, what's the how the system should, uh, or what's the expected behavior of the system. So the design everything from the this one from the analysis or any documented or any document that produced here, and then this one is the coding or your programming. This one is developer. You will develop the system, and then after develop, the tester or QC quality control will test the system and then go for installation and maintenance. Basically, you only need to know these five, I think. This, if you know these five: process, planning, analysis, design, implementation, maintenance, should be okay already. So as you can see from this diagram, not diagram, yeah, from this diagram, the process 3, 4, 5, 6. There are seven phase here. You can see after one phase, it moved to another phase. That means one after another, and you cannot see any like there's no like go back process for some model. For example, after you already design and then you after you already analysis, after you done your analysis, you can go back to the analysis before you design. That can be example of iterative model where you can go back, but for this waterfall, it's like it's in sequence. So this is the example. So after testing this now, go for installation. Installation is after you already done your program. After pass your testing from tester or quality check, you will usually technical, it's not technical, support people from your company will do the installation. That means after already done, you will migrate the system to the client side. That means you will implement to the client side. And then maintenance. Maintenance if already go, there's a term, go live. Go live is actually a term that go after you already implement. That means the user already used that system. That's the term with go live. Go live is already used by the user. Even after used by the user, your system can still have a bug or issue. So this process is known as maintenance, where you fix the bugs that's already go live. You fix the bugs where it's already in the production server. Production server is a server where you already uh, save your system. It's already used by the user. So basically, this is the waterfall model. I think you can understand. You can just remember this 5 step: plus planning, analysis, design, implementation, maintenance. This is the most typical one. But really in your reality, I don't think there's any organization or anyone using this anymore because there's no there's no like perfect system after you already design or after you already design and then you go for the implementation. No, usually after you design you still got error, and then even in maintenance you still go back to here design. So in reality, this is just a concept you need to know, but in reality there's no such thing. Yeah, I think you can read from here the difficulty of returning to an earlier past. So you cannot return to previous past. Then we move to, guys, do you understand with waterfall model just now? Any question?
Yeah.
Yeah, okay. So we learn to how we can apply this waterfall approach. So like I said just now, this method or this approach is applied in a linear sequence. That means after one, you move to one phase and then you move to another phase. You didn't or you cannot go back here. You cannot from the testing, you go back to design. So it's quite difficult actually. So that's waterfall. This often result in discovery during testing activities when the different pieces of system are integrated of quality return. Okay, here from the second point here, you can read that this often when different pieces is integrated. Okay, for example here, in the second point, it's try to tell you that this waterfall model or this particular model, it's quite difficult because usually after we already, let's say we already in the third phase, integrated should be on the, integrated should be here in the implementation. So that's meant after we already implement or we already deploy our system, then only we find bug. Oh, then only system error occur. So it's quite difficult actually for us to go back to the previous phase. So that's why waterfall model is not really a good framework. And it is also quite a problem if any bug or any system error is discovered late in the development process, because it may be too late to resolve them or maybe too costly to resolve. Okay, for example, the last point here, for example, in this phase, let's say you already test, let's say I'm as a tester, I already need to test UAT, you need acceptance test, I need to perform a UAT. Then I found like a bug. It's not expected. The behavior is not expected. And then we need to go back to this analysis. We need to check back. Is this the requirement or the expected output from the bug there? So it's like quite complicated because we need to go back here and then it will be taking more time to deliver your project because there will be some changement, and obviously it will cost your company more than uh what it should be planned in the first place. So this one, okay, already discovered that, like I said just now. Oh, this is, oh, okay. So this is the example, the explanation of each of the process. So the first one is system engineering. System engineering, like I said, this phase just now is the planning phase, where you need to have all the specification, all the requirement or any documentation that the client thinks it is important for us to know. So this is a planning, and then requirement analysis. Requirement analysis. So after you do your planning, you need to analyze. So you need to analyze. This is where you analyze all your requirement, which mean this is all your this phase is where you should have your diagram. Yeah, this is the phase where you should have, like, for example, if you want This phase should, this is where all the phase that will request or will need all your documentation, either it is in diagram form or anything. Usually, this is the phase that involve, or usually this is the phase where the system involve your UML diagram, DFD, ERD. This is where they will see before the design. So this is functional specification, acceptance test, and specification. Yeah, they also need to produce, or they also need to come out with a test specification or test script which will be used here. That means anything that you will need in this phase, they should analyze here. Usually, yeah, and then the design. This is the part where they will design the whole system. Usually will involve the programmer, system test specification, design specification, subsystem, unit test specification. Oh, basically this is where you design, where you need to check back or to, yeah, you need to check from your the result or your output from your analysis here. This is where you will design. You will design based on the output here. And then next we have construction. This is where we do development or coding or programming. This one is involved. This one programmer, developer will involve here in your programming or coding. And then after you already program, after done already, usually, usually how does the programmer work together with tester is, for example, one big system, they don't deliver this one, for example, your student management system. Usually they will deliver to the tester or to the quality analyst to test is by module. They don't deliver the system like one whole system after they finish, then only they pass to the tester. Usually they will submit or they will pass through like module by module. So it will be easier for both party, which is the programmer and tester. Yeah. So testing, and then usually this will, in this whole process, the most time will be used here in the program code and testing. Usually they will have some passing between these two phases, construction or coding and testing. Yeah, coding and testing. Sometimes for complex system, it can take up to 1 month for just one sub module. And then after you already test, Mm, testing. Testing involve the unit test report, subsystem report, system test, acceptance test, and compile system. Actually, for testing, not only some people they think work as a tester is easy because you just need to test whatever done by the programmer. Actually, working because I joined the testing team before, so actually for testing team also can be quite hard because you will argue a lot with developer because they will developer will always claim that what they done is correct, and then the us tester need to clarify why is it wrong, or you need to check back your the requirement here, and then you need to justify or argue with the programmer why is it wrong. But after you done your testing, okay already, you need to come out with a report. There are so many report here, but usually we only use actually there are many report here, but usually people will only come out with UAT. Yeah, UAT report. UAT is a user acceptance test. That's mean whatever done, whatever tested here is correct already. So you need to come out with a report. You need to state whether it is pass or fail. This is on testing here. Mm, installation. Installation, like I said just now, installation is the where we migrate or where we migrate to the where we let or where we save our system into the, I mean, how do I say, installation is like already test, right, already passed, so we can let the user, we can install the system to the our server. That means the user is can use. Usually for big company or a project that I involved before, they don't, for example, testing, they have a different server. You guys know, right, what is server? I think you guys should know what is server. So they have different server between the user, no, between the what the user and the programmer use and the production server. Production server or where production server is where the user or where the real data, or let's say you have student management system, you have a real data in the production server. So that's where you need to migrate or you need to install your system into the server. And then this one usually done by the support team. The support team will do the migration or will do install the system. And then next we have maintenance. Maintenance is the last part. Maintenance, that means already used by the system. Let's say you guys already use the student intranet system. So the maintenance will take part if they have any any bug or any error reported, or you guys or the university or the college want to add module. So this is where the maintenance part, like change request. Yeah, change request, they want to change anything. Change request report. Which part longest usually? Ah, the longest part but yeah, the longest part usually between these two, construction and testing. Actually, I will, I think my, I go back to my, I draw something just now. Okay, like I said just now, basically you need to know this 5 P's. So the longest part will be here, design, because design contain the construction and testing. The programming, yeah, the usually the programming will take more time than other phases. The programming, even though after they already passed, they will programming after they already done, they need to send to tester. Yeah, tester or quality assurance tester. So even though they already passed to tester and then tester found bug, they need to pass back to developer. So usually there will be regression testing here, which like bug fixes and then pass back to tester and then bug fixes again, tester again, bug fixes again, test again. So usually in this phase, construction and testing, which is in design part, usually will take the longest time in your development. So am I answering your question, Kelvin Shark? I think yeah. So the design part, uh, which involve the testing and construction. But usually between the construction and testing, by logic, it will be on your coding. Coding will take the longest part. Coding will take the longest part. For example, if the coding take 1 month, the testing can take 1 week to complete. But still, they are in this phase between these two. So later, if you work as a programmer or as a tester, you will argue a lot with your colleague. Analysis, design, construction, testing, installation, maintenance, maintenance. Okay, basically, this is the process of your waterfall life cycle, SDLC. You need to know, yeah, you just need to know what's the phases in sequence. And then strength of waterfall life cycle. The first one is task in phase may be assigned to specialized teams. Like I said just now, for each phases, there will be a team that assigned to the phase. Like I said just now, system engineering, requirement analysis is by business analyst, design, construction, testing is by programmer and tester, installation or migration and maintenance by support. So each phase have their own teams, but they're still working together. But they're assigned to specific phase, of course. Project progress evaluated at the end of each phase. Yeah, for this waterfall, for each phase, you will evaluate your phase. Does it, for example, for let's say analysis. So we will evaluate, does we complete the all the analysis, or do the requirement or the specification documentation already complete before we can pass to the programmer. So it will evaluate for each phase. But again, in this programming or construction, usually the developer want, usually it's very normal actually when you're working as a programmer, whatever you test in your local is your PC. That's mean you do coding in your PC, so your PC is your local. Whatever you write in your local might work, but whatever you pass to the tester can produce an error. So you need to identify, or you need to see what the root cause of the error. So project progress is now managed with high level of risk. The emphasis on requirement. The third point is, okay. The third point is, I think you can start from here. The emphasis on requirements and design before writing a single line of code, ensure minimal wastage of time and effort. Okay, that's mean here in the design process here, um, usually they will design, or they will come out with an overview of your code, or overview how you're going to write your code, or how you're going to implement it. But yeah, because it can ensure the minimal wastage of time, because you want to reduce the time to develop your system and reduce the schedule slippage of constructor expectation are not being met. That means you need to design everything properly before you, I mean, you need to design properly so that it can deliver on the time and meet the consumer expectation. Yeah, that's mean you need to design everything so that every phase will follow accordingly. You did follow the schedule set by the project. But like the question just now, Kelvin Shark asked which part takes the longest usually. So as you can see here, there are few phases, 7. Well, actually, basically there are only 5. Usually, when they design the time or the Gantt chart is guys, do you know what is Gantt chart? Have you ever learned about Gantt chart? Gantt chart is like your time, like a schedule. Yeah, it's like a schedule for you to, let's say you have 1 month. For example, you have 1 month to complete one system. So let's say in first week, what you should have done, second week or third week, what you should achieve. So they will design all the time, and then usually they will focus, or they will give longer time to these to to phase here, construction and testing. So they can design, and they can, yeah, they should design the Gantt chart or the timeline so it can meet the user expectation. And then the last one is this one, the last one here, I think the same with the second point just now. The stage, development cycle, enforce discipline. Every phase has a defined start and end point, and progress can be. So yeah, for each phases, you need to know, and no, we need to know that what should we do, or what should we achieve at the end of our phases, at the end of our phase. For example, yeah, from this requirement analysis, we need to know what do we need to have, or what is needed for these phases. For example, you need to have like the specification, requirement specification or non-requirement specification, or any document that can be used for you to complete this one phases. And then you need to be clearly what is your output, so you can move to your to the next phase, which is design. So you need to know. I think this one same with the second point. So, oh, this is the criticism. criticism, or why waterfall is, I think, for you guys, even though you will learn this module in this course, but I don't think you will apply this knowledge later in your industry. Uh, for example, last week I received a phone call from my friend because he need to attend an interview, and then they have a question that asked him. So he asked me back, what is waterfall development? I mean, my friend asked me, he referred to me what is waterfall model, because he have, I think, 5 years experience in the industry, but he never encounter or he never apply this waterfall module or framework. So I think you need to know this, but you won't see this or you won't apply this later, because because I don't think people apply, but maybe some. But by the way, I think this is the disadvantage or the bad side of waterfall model. The first one is real project rarely follow such a simple. Yeah, this one that I said just now. It's very rare for you to follow. Let's say after you already this one, after you already done, if you follow this waterfall model, let's say after you already develop, after the programmer already developed, it's very rare. It's very rare. It's quite rare. It's really rare. After you already develop, you pass to testing and then it's passed. I mean, the whatever the programmer done here, it's very rare for them to code it correctly. There must be something missing or some error or some bug that they found. So that means the tester need to pass back to the programmer here. So it's very rare. Like they follow everything in sequence. Even in reality, even you already done here in the maintenance, sometimes you need to go back here in your analysis. You need to find back. Let's say you find bug here. Let's say your system, the system, student management system doesn't act or the behavior is not as expected. You need to go back here. You need to check back here. What is the problem or how the problem can occur or why the developer caught the program that way. So it's very rare actually. The iteration is almost impossible. That's mean iteration. Iteration. What's I mm, iteration actually is like when you're doing coding, you should be familiar with this. Iteration is like the, how do I say this? Like the repetition. Yeah, it's like a repetition, but it's almost impossible. Why iteration is almost impossible? Plus iterate. No, iteration is like one to next. I think in this concept, in this waterfall model, iteration is one phase to next phase. That's mean this second point is supporting the first point just now, because after it's quite impossible after you finish one phase, then you move to next phase, and then you move to the next phase without any error. Yeah, I think that should be the definition here. And then the third one is lapse time between system engineering. Lapse time between system engineering and the final installation requirement might change. This is so true. That means system engineering is the first phase of your cycle, and then final installation. Let me show you lapse time between requirement might change. Like I give you example just now. Let's say if you have problem here, you might need to check back your this phase, the first phase, which is planning, and then you need to, yeah, it's possible for you to check back even from the last to the first phase of your system. But that is not a good practice actually. Your requirement might change because even though you already implement, sometimes the user want to change the system, so the requirement might change. And then and then here, unresponsive to change during project. Yeah, why waterfall is not really used in the industry or is not really applicable, because if you want to change anything, it's not like, how do I say this? unresponsive to change during project. So because the nature of this module is one phase to another phase. So like if you want to change anything, then you go back to your previous phase. It's very, it's not that good actually for your development life cycle. So that's what is unresponsive to change. It's very hard for you to do any change actually. You need to follow the process exactly. User or business needs requirement not addresses. User or business needs requirements not addressed. Oh, I think because you already follow the waterfall, right? Let's say you already found a bug or your requirement, the user requirement is not met. And then you cannot go back to change anything from the requirement. You already implement your system. You already implement your system, but then you want to change something. But of course, by waterfall phase, you cannot go back to the previous patch. But in reality, no one use waterfall, so you still can change anything. But according to this module, you cannot go back to the previous patch. Modules not integrating, yeah. This is the same concept like I said just now. Difficult with maintenance. I think this is all the same. Difficult with maintenance, let discover of flaws because they cannot go back. Poor quality of end user experience. Yeah, let's say the user complain or want to implement something. They said, can you add this or can you add this? Let's say for your student management system, you want to add another function or another module, but based on this module, you cannot change already because there's no turning back to your phase. So user experience. You guys, what is user experience? Never mind. I'll explain. Experience is like, uh, I think from the term itself, the experience of the user when they use the system. Is it easy for them or how easy the system used by the user? That is user experience. It's very important actually for user experience to usually when we want to design a system, we will one of the element that we will consider is UI and UX. UI is user interface, UX is user and experience. These two terms usually they will come together, UI and UX. And then trace symptom to root cause. What is this? But guys, so far do you understand my explanation just now? Any question? No.
No, no.
Okay. Okay. Then we move to symptom to root cause, symptom root cause back practice. Okay. I think this is it the same? Yeah, I think this one is about hmm, how to maintain model do not fit. Okay, okay, okay. Trace symptoms to root causes. Usually, so usually, okay. This is the example. Mm, trace symptoms to root cause is actually mm, how do I explain this? Module example. This communication. Let me think. Sometimes when we're developing or we want to design a system where we develop or we want to design a system, sometimes after we already at the last phase, which is uh implement it's not last phase, it's on second last phase, which is maintain implementation. Even though after you already implement your system or your module, then the user use the module, and then the user found out that the modules don't fit or the requirement is not as, or the output is not as expected from the requirement. So what you can do by doing this is you need to track back or you need to find the root cause, which for example here module don't fit. You have a system and your module doesn't fit with the system, and then you need to identify what is the root. what is the cause of this issue, which is ambiguous communications and undetected inconsistencies. That's mean here during your development or during the system development life cycle in the design, you have like misunderstood something here because you don't have a proper or clear explanation on what the output that should come from your system. But how you can encounter or how you can tackle this problem here, this module that for example here, the problem is module doesn't fit. So the root cause is here. But how you can encounter or tackle this issue here by doing this model visually UML. So this is the diagram. This is where I said just now, you need to know the diagram because it's easier for you to explain to the team what is the expected or the requirement needed. So this issue here won't occur, won't happen, or won't observe in your system. So that's why we need to have a phase in our system development cycle because we can, for example, for before this, when I was still a student, I don't really apply this 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 phase or any module. We usually when we want to develop a system, we let's say previously I developed a mobile learning application. So when I develop a mobile learning application, I didn't go through the phase accordingly. That means I jump to the third phase, which is design. I design, which I skip the first phase. First phase, which is planning and analysis. And then at the end of my implementation, when I already develop a mobile application, then suddenly I have problem with the user user requirement. What I develop doesn't really meet my requirement. So I need to go back to the earlier page, which I need to design everything back carefully, and I need to come out with a model, any diagram for me to understand my design. So that's why the best practice for you first is you need to know what's the requirement, what's the architecture, basically. But what no, I mean what's important is you need to know your requirement so that this problem you won't encounter. For example, manage requirement is one of the requirement is you can for example, the time, the schedule. You need to manage your time properly so that you can avoid this issue, late discovery or no, late delivery. Delivery mean that you fall behind your schedule. That means you deliver late to your client or system. You you doesn't follow your schedule. So you need to follow this best practice to avoid any symptom or any error, unexpected behavior for your system. So this is the symptom to root cause. Just symptom to root cause. I think here is they're trying to tell you if you have any error or you encounter with any bug, you need to try to root cause or try to identify what's the root actually. Actually, it's very easy. Last time when I joined the tester, when I joined the testing team, I still remember. Even though I'm working as a tester, which I because tester or quality assurance, we doesn't need to involve with the coding. Coding will be done by the programmer. So we doesn't need to involve, we doesn't need to see the source code. Source code is your coding. Source code is your coding. So tester doesn't need to see the source code. But last time, when I was a tester, if there's any error, we need to find the root cause. So we need to check the coding. We need to advise the programmer where you can actually change your code or what's the root cause of your issue. So actually that's basically what is it meant by this one. And then the best practice reinforce each other. This is how you can avoid or how you can avoid the any unexpected process in your system development life cycle. So the best practice is develop iteratively, manage requirement, use components, model, UML, continue. So for each phases, actually, as you can see, here, there are for each of the, this is not phases, but this is like a practice or what you can do or what can be done to avoid the problem or the issue. So you need to develop iteratively. Iteratively, that means you need to follow the sequence. You need to follow the sequence. And then manage requirement. Manage requirement, ensure user involved, requirement involved. This is very common because when you manage your requirement or any documentation needed for your system, it will involve the user and the business analyst. And then use component architecture. I think this is basically, this is the best practice and the best the explanation on what can you do or what you can done to avoid the error. I think this one you can understand. This is like a practice only. This is not include in the phase just now. This is your practice. So later I think you can read this. And then software architecture. Okay. First, software architecture. Architecture actually is a component or element, or for example, you want to develop a software. So what is needed for you in order for you to develop the software? So that is software architecture. So your software architecture needs to be component based and resilient. Resilient, if I'm not sure, the definition of resilient is um, your software architecture need resilient. The meaning of resilient is successful. So your architecture, software architecture need to be successful. That means whatever you use need to be able to use, like no room for error. So we go to this one first, component based. For component based, we can reuse or customize components. This one, reuse or customize components. That means you can use any component that already used before in your other project. You can reuse them back. Select from commercially available components, evoke existing software. Select from commercially available components. This one, I'm not sure. I don't understand the second point here. But evolve existing software incrementally. Evolve. This one too, these 2 points I'm not understand. But your software architecture need to be component based. That means your architecture of your software or the elements need to be on component based. And resilient. Resilient, that means successful. So that means no error or no bug. Everything can be used. Your component can be used. So meet current and future requirement if both and capture system dependency. This one is this is a software architecture. This one I think I will the general, this one, the subject here, I mean the explanation here, I think we can understand, but the explanation here, me myself, I don't understand. So I will get back to you on this page on next lecture. So we move to review question. So I think we can do this for now because I think this is quite easy. So there are 3, 4, 5, 6, 7. So there are 7 phases here. So the waterfall life cycle stage, the first one we need to arrange is system engineering. System engineering is the planning part. And then we go to the analysis, requirement analysis. And then after we already analyze everything, we will go to design the system, which consists of construction, which is the programming part. And then after already finished developing, we go to testing. And then after we already test, we can install. We are good to go to installation. And then the last phase will be maintenance. So this is very easy. Correct stage. Oh, program code. Program code is in change request and report is in change request and report should be in change request and report should be in analysis. No, change request. So high level of architecture should be in system engineering. Install system is installation. You need to know this part because this exercise will help you actually to understand each phase of the life cycle. Here in report should be in testing. Testing because of the test report. So after you already done your report, you need to come out with a testing. After you already done your testing, you need to come out with a report to inform whether pass or fail, and then system. System. This one is requirement. Specification, requirement, functional acceptance test. This one is RA. Yeah. So this is what they involve. Yeah. This is where the phase is involved for this of this item here. Then we move to okay. This is the large patch for waterfall. So before we move, do you guys have any question for waterfall? No.
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 Okay, okay. We move to Unified Software Development Process or USDP. USDP, I'm quite new to this to USDP, but I think I study. So USDP, or known as Unified Software Development Process, is a generic software development process for OO and design. Basically, USDP is a framework. Yeah, it's a framework that shows the incremental development. That means after you already done one phase or one part, what should be the next part or next phase? So USDP shows the incremental development process. Yeah, incremental development process. So this one is the basically USDP shows the, you can read from the third line here. We can skip the second one. We will go to this third line here. This approach or this process describe the key concept or the core workflow and the overall management required for the development of generic software development process. So by doing this, by using this USDP, you need to have the idea or the concept and the core workflow. Core workflow doesn't that mean it doesn't need to be specific. The overall workflow, like the overall overview overview of your system flow. Yeah, the keyword is overall management required for the development. So this USDP doesn't need to be specific, and it's quite different with the waterfall just now because USDP is a best practice in the system development because you can adopt the iterative and incremental approach. I think there are four, which is interception. I think there are four, it's not I think, there are four main phases here. I think we will go each of the phases later in this lecture note. So different tasks are captured in a series workflow. Okay, that means for task can be used with a few workflow. I think it's okay if you guys don't understand this, but because we will go later. So the USDP embodies work. Okay. Okay. So here the USDP, generic software development process for OOAD. So generic software generic software rollout. So basically generic software development process for OOAD. That means this unified software development process is is allow you for example like just now waterfall model, it only by you cannot go back to your previous phase, but for unified software development process you can allow you or you can there's a I think there's one keyword different I read it somewhere. Wait hmm. I think we can skip this part because I will explain later here in the diagram. I think you will understand more in the diagram. So I skip this part here. Describe key concept, core workflow, overall management, and what is best practice. Yeah, I'll skip this part. But by the way, do you know? I'm going to tell you why this is the best practice in the system development. Because for this USDP, there's a room or there it is quite flexible, quite quite flexible. That's mean it's not compulsory for you to go to next phase. Next phase, if you already done one phase, that means you can already go back to any previous phase before. So that's why it is the best practice because that's the reality. You can always go back to your first phase of your life cycle. So like I said just now, there are four phases: interception, elaboration, construction, and transition. So the first phase is inception. So this is the requirement gathering. Requirement gathering is where you capture or requirement gathering is where you capture all your where you requirement gathering, I think you can understand. Requirement gathering is where you capture all your requirement or anything needed for you to for needed in your development process. And then the second one is elaboration. The elaboration is focus requirement capture and determine the structure of the design. Okay, elaboration here is after you already did your first phase here, after you already get your requirement, you need to like how do you say this? Class like this is where you done your analysis, and then you come out like with any diagram. Any diagram, for example, UML, DFD or ARD, like the elaboration is where you analysis your requirement from the first part. And then we move to construction. Construction is the what is now construction? Construction main aim to build the software system. This is after this is I don't understand why they use I think the term here is quite hard. Construction is development. Development is coding. The main aim to build the software system. This is where the coding part will take place, where you will construct your system. And then the last part is transition. Transition is deal with product installation and rollout. So this is the last phase. But I think you guys still need to know the term here, even though I think they can use easy word. But never mind. So transition deal with installation and rollout. Installation is where we put our system or our software or our application or whatever our output is, we install them and we let the user use. And then the rollout here meaning that we totally we totally let the user use our system. That's mean rollout. That mean we already leave it's not leave the system. It's like our fast is already done. Distribute. You mean deliver? Deliver? Oh yeah, I have the word here. I remember. Here rollout is like deliver. Deliver after we already deliver our system to the expected user. Distribute. Yeah, I think distribute also can be used. Distribute the system. I still don't understand why they use. I don't know why the term here it's quite hard for me. But this is the basic phase of USDP. So this is the diagram that I want to explain to you guys. This is the diagram that I want to explain. Okay. Yeah, like I said just now, basically there are only 5 phases that you need to know compared to 7 phases just now. So the phase is requirement, analysis, design, implementation. This is not the ADIM. Actually, test, requirement, analysis, design, implementation. Actually, this is no. Actually, no. This is not the first just now I said. By the way, this is the first. It's not the first phase, but this is the first interception that you can allow. How to explain this? Okay, the size of the square. I think we can use this diagram. How do we use this diagram? Never mind. Okay, as you can see here, there's a diagram. Okay, you can see there's a different size of square, this shape here. So the if you go to the next slide, you can see size of square relative to the time spent, oh, the time spent on the workflow. This means the size here. I'll explain. For example, the requirement. Okay, here you can see the requirement. So this is inception. Inception previously I said is the requirement gathering or requirement capture. So you will use a lot of time here in requirement gathering and requirement capture here. And then project phases. Apa ni? Guys, I'm also not sure how to explain to you guys this diagram, but project phase is iteration. That means workflow, size of square relative to time spent. I'm not sure the diagram here, but project phase 4, workflow. Workflow is the process. Project phase, process. Okay, guys, I think honestly, I don't understand this diagram. So I do not know how to explain. I'll explain this later. I don't understand too. It's my typewriter. It's true. I don't understand. Best practice, iterative, and incremental test. But guys, before this slide, do you have any question you want to ask? Because honestly, I don't understand this patch, this diagram. I think this should be this patch, the faces here, should be our last. We should stop here for today. Yeah, we should stop here for today because I don't understand this diagram. I do not know how to explain to you guys. But basically, what I understand from this diagram is there are 4 phases, and then workflow is a process. But I do not know how to explain what's the relationship. I will explain later in our next class. So guys, for today, I think we can stop here. Do you guys have any question you want to ask for today's lecture?
Um,
Anything you want to?
so far for me, no lah.
Okay, since no question, but I want to. This is for different for our other class. I have announcement for class research methodology. Wait, yeah, for research methodology class, I will post this announcement later too. For this date, 21st August, which is on Saturday, on your week 9, you will have a midterm test, which is on this date. So I want to book this date because it's on Saturday. But this one later I will post in the classroom. Yeah, I will post later in the classroom. I just want to announce this earlier so that you can book this date, 21st August. You have a midterm test for your research methodology class. Yeah, and then one more thing, I want you to check your attendance because last week I update your attendance quite late, I think the end of your week. So later if you have any problem with your attendance or I miss out your name in the list, you can inform me. So the two things I want you to do is book your date and then your attendance. So I think that's it. Do you guys have any question? No, right? So that's the end of our class for today. Oh, it's raining. Yeah, that's the end of our class today. So thank you guys.
Okay, miss. Thank you.
Thank you, Miss.